Alright, let's look at homework 2.6, problem number 9. Alright, so we have f of x kind of sandwiched by two functions. So this is a great setup for a squeeze theorem. Alright, so let's take the limit of the smallest guy and the largest guy and to see if they go to the same place. If they do, f of x is going to have exactly the same limit. Alright, so let's do that. Alright, so we take the limit of the smallest guy, 12e to the x minus 23 over 4e to the x as x approaches infinity. Right? And again, the trick is, divide top by 1 over e to the x. And multiply top and the bottom by 1 over e to the x. Alright, that way we're going to get limit as x approaches positive infinity. Right? Then you have 12 e to the x over e to the x is 12 minus 23 over e to the x, and then you have a 4 on the bottom. Right? As x gets larger and larger, e to the x gets larger, so 23 divided by a really big number approaches 0. So what's left is 12 over 4, which is 3. Right? So this guy approaches 3. Right? Right, so we're hoping that, the other guy, the largest guy, so limit as x approaches positive infinity of 3 square root of x over square root of x minus 1. Right, the trick is we multiply or divide by square root of x. Right? This way, you will have limit as x approaches positive infinity. Alright, 3 on top. Alright, so you have a square root of x divided by x would be 1. And negative 1 divided by x is negative 1 over x. Alright, so we see that the 1 over x approaches 0. So what's left is 3 over square root of 1, which is going to be 3. Right? As we were hoping that the smallest guy and the largest guy go to 3, so therefore, by squeeze theorem, so this tells you that by squeeze theorem, we know that the limit of f of x as x approaches infinity is equal to 3. Alright, so let's type it in. Alright, so this is going to be 3. Alright, submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.